Hello everyone, I'm Guangxin Zhao. This is my project, Predict Obesity by KNN, Decision Tree, Logistic Regression, and an Ensemble Model. Compare their results and choose the best model for dataset. My data comes from UCI website, and the name is Estimation of Obesity Levels based on eating habits and physical conditions. The purpose of this project is build the model and identify the best model for the dataset. This is the structure of this model, and we can see it includes 21 11 observations and 17 variables. Some variables are numeric and some are categorical. Now I download the data from the website, and I explore the data with the plot of each variables. And we can see this is on the plot, and this is the plot of the target variable, the obesity level. So the target variables of this data set include 7 results. In order to make the targets easy to analyze and let you can easily to understand, I will separate those 7 variables, seven results into 2 groups. One is obesity group and another is non-obesity group. So obesity type 1, obesity type 2, and obesity type 3 will belong to obesity group, and the rest 4 will be non-obesity group. The distribution of those variables were checked by superior work test, and we can see that the p-value of those 3 variables are smaller than 0.05, so it means all of them are not normal distributed. And then I identify missing value, but there's no missing value in this data. So I randomly choose some rows and assume that some rows miss their height value and some miss their weight value. And then I use the 10% trimmed mean of weight and height based on the gender to impute to the missing area. As I described above, I separate the target variables into 2 groups. Obesity type 1, 2, and 3 in obesity group, which is indicated by 1, the rest 4 in non-obesity group, which is 0. And then I encode binary variables and categorical variables. Binary variables, I use one-hot method, and the categorical variables, I use the label encoding and the frequency encoding method. For KNN algorithm, we need to normalize all numeric variables. So in this case, I use Z-score method to normalize the variables. The reason why I use Z-score because Z-score can also used to identify outliers. So if the Z-score smaller than -3 or greater than 3, we will remove the number. I use 3 methods to check the correlation between each variables. The first is VIF, and from the result we can know weight and height may correlate with another variables. The Pearson coefficient of height and gender and height and weight are high, so those may correlate. And the result of chi-square, we can see the p-value of gender and smoke are greater than 0.05, so which means those 2 variables may not relate with the target. PCA usually used to reduce the dimension of data. people usually choose the first two principal components because they may keep the most variance of the data. But in my data set, we can see the first two only occupied around 27% of the variance. Therefore, I may choose more pieces, maybe the first 7, to keep more information. And then, as I talked before, those variables are not normally distributed, so I transfer them with their log number. And we already realized that weight and height may correlate with another variables. So I combine those two variables into a new variable called BMI. And the BMI is calculated from weight and height. And then I add the BMI column to the dataset. And we can see the BMI and the obesity may strongly correlate together, strongly correlate with each other. And then I make the model. First, I separate the data set into 80:20 ratio. And I make the decision tree model with the training data and evaluate it with the testing data. And this is accuracy and F1 score of those model. And we can see it's very high. So it means the decision tree model is very good. For KNN model, we make the model with training data and evaluate with the testing data. And the accuracy and F1 score is also good. For logistic regression, when I built the logistic regression, I first built it with all features, but I find the p-value of all the features are insignificant. So which means the coefficient of them is same as 0. So I remove weight and height because those two may impact the result of this model. And I combine them with the BMI, so I remove weight and height. And then I run the model again. Now it works better. And then I evaluate the logistic regression, and this is the result. And then we compare with the performance of the 3 modules, and we can see decision tree is the best one. And then I evaluate the 3 modules with k-fold cross-validation with 10-fold. And as a result, when k is equal to 5, the model is more close to the real data. And when the CP is equal to 0.00027 of the decision tree, the model is close to the real data. And for logistic regression, there's the one result. Even the RMSE number is small, but compared with the previous 2 results, logistic regression model, it's further than another 2. And then I turn the model based on the result of previous analysis. So for KNN, I choose 5 nearest neighbor. And for decision tree, I use 0.00027 CP. And for logistic regression, I eliminate the non-significant variables one by one. And this is the final model. And we can see all the variables are significant. And then we collect all the all the results of the original model and the turning model, and we can see for KNN it improved. And decision tree it's same, and for logistic regression improved a little bit. And compare the three turned model, KNN and decision tree are the best. And then I built random forest model. And we can see the random forest model is also pretty good. Then I combine the logistic regression KNN and the decision tree model with majority voting method. This is a function for majority voting, and I make the prediction by the ensemble model with the test data and evaluate the model. And the accuracy at F1 score of ensemble model is also very high. So I collect the result performance of all the 5 models, and we can see KNN, decision tree, and the random forest are the best. The performance of the logistic regression is not good as the rest 4. I think because the in original data set, the target variable it's 7 results. But we know logistic regression is good for binary target. So maybe logistic regression is not very suitable for this data set. In order to check whether our ensemble model is work for the new data, I create a new data set with 10 observations, and I encode the categorical variable, normalize numeric features, identify outlier, transform the log number, add the new features, and then I make the prediction with the ensemble model, and this is the result of the new data. So it means my ensemble model actually work. So in this project, I successfully built KNN decision tree, logistic regression, and the random forest model. And I also successfully create the ensemble model. I compare their performance and choose the best models. So all my purpose are achieved. I do learn something from this project. For example, I can use VIF to check the correlation of each variables. And if we find some variables correlate with another variables, we can combine the correlated variables into one features, and then we can use the new features to build the model. The function of my ensemble model is only used for the prediction part. I think if I can put the 3 models in this function, it can help me more because I can work more easy and convenient. Thank you, everyone.